Hello, and welcome back to our first maths lesson of this week. Now, it's a change of unit in maths this week as well. We're moving on from multiplication and division into fractions. Now, quite often, the response to fractions is, oh my God, I can't do this. And hopefully that will change as we go through. We'll try and make it as simple as we can for each step and try and just to work on what we already know in order to go forwards. And remember, you can always go back and watch previous videos in order to try and understand what we're talking about. So our first thing that we're going to be talking about is the key vocabulary. And what we need to talk about are the different parts to your fraction. So what you have is the number on the top, so in this case, A, which is the numerator. And this shows you how many pieces you have of your fraction. So if it was 1, I'd have 1 piece. If it was 2, I had 2 pieces. And this can be any number. B down here is the second part. It's your denominator. And this tells you how many the parts that the whole is split into. And each of those parts needs to be equal. It's not a fraction unless each of the parts that it's split into are perfectly equal. So if the denominator was 5, the whole, whatever the whole happened to be, a shape or a number, would be split into 5 equal parts. And then the numerator will tell us how many of those parts I might need. And then you have the line that separates them, which is this bit here. Now, the fraction bar, which is this, separates the denominator from the numerator. And it's a simple full division, so it's the same as the division sign. If you look at it, there is the division sign. And what it's saying is whatever A is divided by whatever B is. And that's what this means. So if A was 1 and I had B, which is 2, my whole, whatever it happens to be, my shape, would be divided into 2 equal pieces. If my denominator was 3, then my whole, my 1, would be split into 3 equal pieces. And that's all that it means and how they work. And I'd have one of them, which would be this 1. If this was 2 divided by 3, I would have 2 of them, but it would be split into 3 equal pieces. Okay. So let's move on. So this is just a quick recap, see what we can remember, and then we work from there. So first question, what fraction is shaded in red? Section 2, number 2 is what is more or less, so the shaded part is more than less than a third shaded. So is that larger than a third or smaller than a third? What fraction of the 7 dwarves are not grumpy? Remember, grumpy is one of their names. And what is half of 72? Pause now and have a go. Okay, so let's have a look. First off, what fraction of the shape is shaded? Well, we've got 2 pieces that are shaded, the 1, 2, out of 1, 2, 3, 4, 5. So the 5 pieces, that's what goes at the bottom, and the 2 ones that we have goes at the top. Is this more or less than a third shaded? Well, it's less, because if it was going to be a third, then they would be equal pieces. So it'd be more like this, and this is much less than the total piece. It's less than each of these two, so it couldn't be a proper fraction. And then what fraction of the dwarves are grumpy? Well, only one of them is grumpy. So the rest of them are not grumpy. That means 6 of them are not grumpy. There he is. Then we've got what's half of 72, and what's half is dividing by 2. So 72 divided by 2 is 36. Now, I'm not saying that you should know all of that, but at least these will be a recap, and we'll go through it as we go along into more detail. So the bottom number is our denominator, and it's how many equal parts there are. And the top number is the numerator, and it's how many parts we're using. So if this was my bar, or my shape, and I was splitting it into quarters. The problem I have currently is that this one is smaller than the rest of them. They're not equal, so that would not show quarters. Whereas if I make them all equal like this, then each one of those are the same amount. So that's 1/4, that's 1/4, that is also 1/4, and that's 1/4. So each of them relates to 1/4. So if we were to put them all together, then we'd have 4 in total. We'd have 4/4 or 4 parts of 4, which is the entire thing. Okay, so which of these diagrams shows a quarter and how do you know? Have a quick look, pause now and have a go. Okay, let's have a look. So we've got A. Yes, this is a quarter. The entire shape, which is the entire square, is split into 4 equal parts, and we have one of them. B, no, because although we've got 4 stars, so each of them could be, these 2 are smaller than the other 2, so they wouldn't be counted as a quarter. This one up here, we've got 4 shapes, and half of them are coloured in. The answer actually is yes, because if I was to move that bit to there, you can see that one of our 4 squares is completely coloured in. So in total, each one of these boxes here is 1/4. And then this one, no, and that's because there's 1, 2, 3, 4, 5 parts. So it would be fifths, not quarters. Remember we called fourth, it's not a fourth, it's a quarter. Here we go, we've got 5 equal parts. 1, 2, 3, 4, 5. 2 of them are shaded in, so 2 out of 5 parts are shaded in. We call that 2/5. Hopefully that should be nice and straightforward. And it doesn't matter which ones. I could have this one and this one shaded in of all of them. I could have this one and this one shaded in and none of the others. It would still be 2/4. As long as 2 of them are shaded in, you'd have 2/5. So the next thing you need to know is another bit of key vocab. And what we have here is anytime there is a 1 on the top of your fraction, it's what's called a unit fraction, which is just one of each piece of the fractions. And it doesn't matter what the denominator is, but if there's a 1 at the top, it's called a unit fraction. And that's because each unit fraction, if you put them all together, would make the total. And there we have it. Doesn't matter what the number is on the bottom, could be 700, but as long as there's a 1 on the top, they count as unit fractions. Any other one, so as long as there's not a 1 on the top, so here we've got 6, 5, 2, any of these, 143, would just count as a non-unit fraction. So the only thing that's different is if it's got a 1, it's a unit fraction. Anything else, it's a non-unit fraction. Okay, so what I would like you to have a go is that these questions here for me. Go through it, see what you can do. This should hopefully, the majority of it be a recap, but it also gives us an idea of what we might need to go through more of. Pause now and have a go. Okay, so the answers are here. What fraction of each shape is shaded? We've got 1, 2, 3, 4, 5 parts, and 1 is shaded, so 1/5. 5 parts, 3 are shaded, 3/5. 4 parts, quarters, 3 are shaded, 3/4. 1, 2, 3, 4, 5, 6, 7 parts, 4 of which are shaded, 4/7. Then this one says, can you shade each diagram to show the representation? There are 6 pieces, 1, 2, 3, 4, 5, 6. Shade 1 of them because I want 1. Or 5, 6, I shade in 5 of them. 5/8, 1, 2, 3, 4, 5 of them. Of the 8, could be in any order as long as 5 are shaded in. And the same here, doesn't matter the order they're shaded in, just make sure 5 are shaded in and you'll have the right answer. Then we're going to circle the unit fractions. So all we're looking at here is any that have a 1 as the denominator. So those 3 are the ones with the denominator at the top. This one here is a recognition of fractions, so you're shading any that show 1/3. Okay, so that's 1 part in 3. Okay, so we look at A first, and we've got 1, 2, 3, 4 parts. So can't be that one. This one, we've got 1, 2, 3 parts, but this part is much smaller than this one. So can't be that one either. This has got 1, 2, 3 parts, and 1 is shaded. So yes. This has got 1, 2, 3 parts, 1 is shaded. Yeah. 3 parts, 1 shaded. We're good. 1, 2, 3 parts, but 2 are shaded. And this one, 1, 2, 3, 4 parts. So it can't be that one either. So we're only looking at D, E, and F. No, D, E, and C. And finally, complete the sentences to describe the shapes with 1/3 shaded. There are 3 equal parts altogether. 1 out of the 3 parts is shaded, so 1/3 of the shape is shaded. Okay, so this is another way to show fractions, is showing fractions on a number line. So the entirety of the number line goes from 0 to 1, so that's our whole, and then it's split into 5 equal parts. And that just shows that each of those parts are equal. Now we want to show on this number line where 2/5 are. So we do 1 jump, 2 jumps, 2/5. If we continue going just to check that we're right, 3, 4, 5/5, which is the same as 1. So 1, 2, 3, 4/5, 5/5, which is the same as 1 at the end there. And there we have it, 2/5 is there. Have a go at seeing where you can spot this, where these go. Try now. Pause, please. Okay, so first off, we just noticed we've got 1, 2, 3, 4, 5 jumps to get to 1. That's good. 1, 2, 3, 4, 5, 6, 7 jumps to get to 1. 1, 2, 3 to get to 1. We know that they are split correctly. So in that case, we just see where 4/5 is. So we go 1, 2, 3, 4. So here is 4/5. 3/7, 1, 2, 3. So I'm expecting it to be here. And then 1/3, 1 jump just to here. We're expecting this one to be where 1/3 is. And there we go. So where is a half here? Well, the problem is this is split into 6ths. So what we need to know is what's equivalent to a half. First off, we might be able to have a look at it and see what we know where we think half might be. But also we can have a look to see what would be half of our denominator shaded in. We've got 6 pieces. 6 divided by 2 is 3. So we're looking here for this 3 being half of 6. So 3/6 is equal to 1/2. And there we go. We can see the number line put on top there, with the half being the same point as 3/6. So which one of these ones, okay, is the same as a half? 6/10, 21/42s, 21/42, 21/42s, 49/100ths, and 18/37ths. Which one of those is the same as a half? Pause now. Okay, let's have a think. 6 is not half of 10, so it can't be that one. 21 is half of 42, so it could be that one. 49 is not half of 50, and 18 is not half of 37. So what we think is 21/42s is our correct answer. Here's some more number lines, and we're trying to place the half onto them or the 7/7 onto them. Be careful, there is a trick question here. Have a go, see what you can do. Pause now. Okay, so the first one we can have a look at, see how many jumps we got. 1, 2, 3, 4, 5, 6, 7, 8. 8 jumps in total, so we're 8ths. Half of 8 is 4, so we're looking at 4 jumps in. 1, 2, 3, 4. So we should think that this will be our half. This next one's interesting because 0 here, this is 1 and this is 2. So actually we only want to count the jumps to 1. 1, 2, 3, 4. 4 jumps. So half of 4 is 2. 1, 2. This is where I imagine a half is. And there we go. And this is the trick question, because actually the total is 2. We only want the difference between 0 and 1, or 1 difference between them. We have 0 and 1 here, but which one's the same as 7 sevenths? And this is interesting, because we've got 1, 2, 3, 4, 5 jumps. Well, the trick here is that we have 7 pieces and we have all 7 of those pieces. Because we have all of them, we already have 1. So it would always be 1 when they match. So what fraction are green? There are 3 green out of 5 in total. What do you think? Yep, 3/5. In that case, what fraction are blue? We don't need to count them. If we know we've got 3/5 and the rest are blue, well, 3, what do I have to add on to 3 to get to the full 5? Is 2, so it'd be 2/5. And we could count them, but we don't need to necessarily. So have a think about this one. We've got 3 questions. Have a go, see what you think. Okay, so the first one should be relatively straightforward. We've got 3 items, so it's going to be a third. And how many do we have which are yellow? There's 1, 2. So we're thinking about 2 out of 3, so it's 2/3. The next one here says, what fraction are not red? Well, we've got 1 that's red, so we can't count that one. The rest are not red, so we can count those. 1, 2, 3, 4, 5. And then we have 6 in total, so it should be 5/6. There we go. And then what fraction are white? Well, we've got 1, 2, 3 white ones, and we've got 1, 2, 3, 4, 5, 6, 7, 8 in total, so 3/8. Think about this one. Is the red shaded area more or less than a quarter? And how do you know? Pause now and have a think. Okay, so the way to think about this is more than a quarter. Even if we say that there are 4 parts, which there are, 3 of them are identical, these 3. But even though they're all the same size, that red one is bigger than all of them, so must be larger than 1/4. So have a go at these last questions, please, for me. Pause now and have a go. Okay, so here are our answers. Much like we've done before, we're just looking at how we answer them. So a quarter, we've got 4 jumps, 1, 2, 3, 4 jumps, and we just want 1 jump. So there's our quarter. 3 of the 5 jumps we want to do, there's 5 in total, so we just do 1, 2, 3 jumps. So 1, 2, 3 jumps, that's where our 3/3 is. Half, but there's 4 of them. So 1, 2, 3, 4. So we want half of 4. Half of 4 is 2. So 1, 2, there it is. Then we've got 1, 2, 3, 4, 5, 6 in total. And I want a third. So I want to divide 6 by 3. Divide 6 by 3 and we get 2. So every 2 jumps is going to be a third. And this is an interesting one because it's pushing beyond what we normally do, what we've shown. But the way to do it is you divide the total number of pieces, 6, divide that by the denominator, which is 3. And then we want 1 piece of that, so we just want 2. And there we go. Draw an arrow to show the position of 5/5 on the number line. Nice and simple. 5/5 is always the same as 1. And then we've got up here, draw 4 different representations of 3/4. And you can have anything you like. There could be different shapes that you draw, and you could have a number line which shows it. There are so many different ways you could draw it that we'll have to have a look, but most of them are, as long as you've got 3 things shaded in out of 4, you should be good. So Amir has drawn some 2D shapes, and here they all are. what fractions of the shapes of triangles? So we've got 1, 2, 3, 4, 5, 6, 7 shapes in total. So the denominator is always going to be 7. And how many are triangles? There's 1. So 1/7. Then it says how many other shapes are square. That's not square, and that's not square, and that's not square. So we've got 1, 2, 3, 4, I would say. So I think that should be 4 sevens. I think all of those are square. Or that's what I would say. So 4 sevenths I would go with. Then so I would say that's 4 sevenths, just in case you've answered it. Then it says, what fraction of the shapes have 4 sides? Let's have a look. Does this have 4 sides? Yes. Does this one have 4 sides? Yes. This one, yep, 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 yep. No. How many? 6 in total, so 6 sevenths. Then it says here, draw 2D shapes to match the description. So first off, let's have a look at the denominator. 1, 2, 3, all of them say fifths. So there are going to be 5 shapes in total. 1, 2, 3, 4, 5. Good. Then 1/5 are squares. So I just want to make sure I've got a square shape in there, and there it is. 2 are triangles, so draw 2 triangles. And it says 3 of them have more than 3 sides. So these could be anything you like. They could be rectangles like they are here, but as long as they're not squares and they've got more than 3 sides, they could be any other shape you like. So you could have them being, rather than this one, you could have had a pentagram like this. You could have had a hexagon, pentagon, anything, as long as they're not squares or triangles and have more than 2 sides. 3 sides, you should be fine. Okay. So that's all for this lesson. I know that fractions can be difficult. So I know that there might have to be a lot of talking we have to go through around different bits and pieces. But what you have to do is just take it slow. If you're struggling, go back and look at a video beforehand, and don't be scared of them. I think half the time that people worry about fractions is that they're scared of them. And as soon as they become scared of something, they don't think about it rationally or don't slow down, just have a look at what's in front of them. I will try and make it as easy as I possibly can. Thank you for listening, and I'll see you in the next video.